Okay, so let's look at practice test 1, question 4b. It says solve the initial value problem. And we're given here x y prime minus 2y equals negative 6x y squared, with y1 being 1/3. So step 1, let's get y prime, the coefficient in front of y prime, to be 1. So let's divide everything by x first. So doing that. So dividing everything by x, we get then y prime equals minus 2 over x, y equal to minus 6y squared. And we need to recognize that this is a Bernoulli equation here. So let me write that. So recall a Bernoulli equation looks like y prime plus some function of x, so p of x times y equal to fx times y to the n. This fits that mold where the negative 2 over x would be your p of x and the minus 6 would be your f, and our n here would be 2. So now let's use theorem 4. So by theorem 4 then, to solve the Bernoulli equation, we're going to make the substitution, so w equal to y to the 1 minus n. So in our case the n is 2. So it's going to be w equal to y 1 minus 2. So it's going to be y to the minus 1 will be our w. Okay, now let's solve this for y. So doing that we get, so raising both sides to the minus 1, you have then y equals w to the minus 1. Now let's take derivative on both sides with respect to x. So doing that we get then, so taking derivative, then you'll have dy dx. Here you have to use the chain rule, bring the minus 1 in front, subtract 1, multiplied by derivative of w with respect to x. You have this then. Now we're going to substitute into our differential equation up here. So in place of the y prime, I'm going to write this, and in place of the y, I'm going to write w to the minus 1. So making those substitutions, we get then, so making substitutions, so again in place of y prime, I'm going to write this. Now in place of dw dx, I'm just going to write w prime instead of written here. It's going to be minus w to the minus 2 times w prime for this guy. That's my y prime. Then minus 2x y, but y here is w to the minus 1. That would be minus 6 y squared. Y is w to the minus 1 squared. Okay, let's multiply both sides of this guy by w squared. So doing that we get then, so multiplying both sides by w squared, so you just be adding 2 up there to the exponent, adding 2 to the minus 1 there, and when you square this it'll be w to the minus 2, then you're multiplying it by w squared, so be adding 2 there also, and that's going to be w to the 0, that's going to be 1, that's 1 there, so rewriting this we get then, so we get minus w prime minus 2 over x, w equals minus 6. And let's multiply both sides by minus 1, so it's going to change all these signs here. So doing that we get then, so we get this then. And then we can actually apply now theorem 1 to this. So let's do that. So we're going to apply theorem 1, where the 2 over x would be the p in theorem 1, and my f function would be 6 here. So let's find our u now. So our u will be then, so our u of x then will be e to the integral of p of x dx. My p here is 2 over x, so it'll be integral of 2 over x dx. Let me pull the 2 outside here, and then integrate. So doing that we get, so pulling a 2 out, then you have integral of 1 over x, which is ln, so it's going to be e to the 2 ln of x. You can bring up the 2 on the exponent on the x, so it'll be e to the ln of x squared. These will cancel, it'll just become x squared. So our u is equal to x squared here. Okay, so I'm out of space, so let me erase a few things and we'll keep going. So summarizing, we have this, we have w equals y to the minus 1, we have this differential equation where this is p, this is f, and we found that u of x was equal to x squared. So let's continue using theorem 1 now. So by theorem 1 then, u times w prime equals u of x times f of x. So in our case, let's make those substitutions. So in our case we have then, so our u is x squared, so the x squared times w prime equals our f, which is 6 times our u, x squared. Now let's integrate both sides. So integrating both sides, we get then we have this then, so integrating this side just become x squared w, and integrating this, it would be 6x cubed over 3 plus some constants. Let me write that here. So we have then x squared w equals 2x cubed plus c, because 6x cubed divided by 3 be this. And let's multiply both sides by x to the minus 2. So doing that, we have, so multiplying both sides by x to the minus 2, we have then w equals, so subtracting 2 from that, it'll be 2x, it'll be c x to the minus 2. Okay, but now we're not looking for w, we're actually looking for y. So let's recall then up here that w equals y to the minus 1, or y equals w to the minus 1. So let's use that. So we're using that y equals w to the minus 1. So we just raise this side to the minus 1. It'll become our y then. So y will be 2x plus cx to the minus 2 raised to the minus 1. Now let's use our initial condition. So our initial condition was y of 1 equals 1/3. So we're going to use y of 1 equals 1/3. So you're going to put 1 in place of x and 1/3 in place of y over here. So 1 in place of x, 1/3 in place of y. So doing that, we get then, so doing that, putting 1/3 in place of y, 1 in place of x, we have then 2 plus c times 1 to the minus 2 raised to the minus 1. This simplifies to be 1 over 2 plus c. And you can see for these two sides to equal, 3 must equal 2 plus c. So it looks like c is going to be 1 then. Okay, so you have then 2 plus c equals 3. So it looks like c is going to be 1. So putting 1 in place of c right here, that'll give us our solution. So hence solution is y equals 2x plus c, so it's 1. It's just be x to the minus 2 raised to the minus 1 power. That'll be our solution. So we're done with the question. So let's leave it there.